Hello there. In this video we're going to go over some strategies that you can use when doing the RS method and the numbers turn out to be really big and you don't have a calculator. So here, for example, we all know that we start the RS by multiplying 60 times 42. And that's a fairly large number. It's like 2,400 and change, some other stuff. It's big. And then trying to figure out what combination of its factors add up to 101, all this without a calculator. So I'm not actually going to multiply these numbers together and write down what their product is. Instead, I'm going to I am multiplying these numbers together, but I'm going to break it into parts. So let's do the prime factorization of this. So 60 times 42, that is 6 times 10, and 42 is 6 times 7. And that is 2 times 3, and that is 2 times 5, and that is 2 times 3, and the 7 just stays. So at the end of things, I have 1, 2, 3 2's, so this is 2 times 2 times 2, and 1, 2 3's, so it's 3 times 3, and then there's a 5, and a 7. And there was the 7 up there. And the product of that, 2 times 2 times 2 times 3 times 3 times 5 times 7, is whatever 60 times 42 is. This is the unique factorization of any natural number into its prime components. Now, some amount of these numbers are going to go on the left, and some amount, the remainings, are going to go onto the right then. And no matter how I split it up, so I could split it up in 2, and then this whole thing over here, that's going to multiply to that. But it's not going to add to 101. That over there is simply too big. So I need some strategy to split it up where some of these go on the left, the others go on the right, and their sum is 101. And I could start down the list and say, okay, well, put the 2 in, what's on the other side? What if I just put a 3 in? What's on the other side? What if I just put a 4 in? But we kind of know that 101, that's a fairly large number, so let's start further down the track. All right, so what if I put all of the 2's and the 3's on one side, and the 5 and the 7 on the other side? Here I got 8 times 9, that is 72, and on the other side I have 35, and when I add those two things together I get 107. So that's close, but it's not 101. So let's fiddle with it a bit more. Well, I had 35 on the one side. It's actually possible to get a 36 because I had some 6's involved. So that would have been 2 times 3 times 2 times 3, and then I would have had one of the 2's left over and a 5 and a 7. So over here that would be 36, that's 70, and this is also just too big, so that's also a no-go. But again, I'm making improvements. So I'm thinking, let's see here, as I push the 35 up to 36, it got smaller. So let's keep pushing it up. Suppose I could go to 40. Let's do 3 times 3, that's 9, times 5. That's going to be the 45. And on the other side I have all of the 2's. There were 3 of them. And I got both of the 3's, I got the 5. That's going to be a 7. So 9 times 5, that's 45. And over here I got 8 times 7, that's 56. And we'll go over here, 45 and 56, that is, oh yeah, okay, that's 101, check mark. So our winning combination was 45 and 56. Now I did have to do a little bit of work here to, trial and error. But there was some combination of these numbers that went to the left. So that was, over on the left-hand side, that was 3 times 3 times 5. And on the right-hand side, that was the leftovers, 2 times 2 times 2 times 7. So you notice that these went to the right, and the other ones, those happened to go over to the left on this one. And nowhere in this problem did I actually figure out how big 60 times 42 was. It's fairly large. Now from here you can do the RS method. The 101 gets split into that, and we see if we can factor those. 15 comes out of the left, and 56 and 42, I'm not really familiar with those numbers, but wishful thinking, RS method tells us that I gotta be left with a 4x plus 3 at the end of it. And 56 divided by 4, well, 60 divided by 4 would be 15, so I think a 14 is going to come out of it. 56 is 4 less than 60. 14 times 3, that does happen to be 42. Both of them got 4x plus 3, and then you look at the bones, and that's our factorization. Those here are 4 and 3, those are relatively prime, so are 15 and 14. I mean, they're not prime numbers. That's 5 and 3, and that's 2 and 7, but they're relatively prime to each other, so nothing's going to come out. And we could test this. Does it reconstruct? That's 60x squared. There's 42. That is 56, and that's 45. And at the end, we got the 42. So it will reconstruct into that whole thing. I don't think we're going to do ones quite as big as this without a calculator, but it does give you the idea for a strategy on how you could do it, where, please note, you do not need to multiply those numbers together. You just need to break them into their prime components and figure out which ones go to the left and the remaining ones go to the right. Okay, thanks for watching. Character and Scholarship for Life.